When you think of acids and base, what comes to mind?
Lemons, baking soda, danger signs of corrosive material.
Well, yes. Corrosion is one of the properties shown between acids and base. In certain concentrations and pH levels, acids and base could be extensively hazardous to our health. However, acids and base play an important role in our life, maintaining some of the function within our bodies. Some that, if they fail, the death of a body is unavoidable. This function depends on acids and base to act as neutralization agent or buffer solution. In a neutralization reaction, H plus ions from acids and OH from the bases react to neutralize each other to form relatively harmless H2O and salts. While in buffer solution, an acid is in an aqueous solution with its conjugate base, which would help prevent the pH changes in a given solution. Have you ever thought about acids and base while doing daily activities?
Like brushing your teeth, eating, breathing, and even exercising? Why?
Because these daily activities heavily affect our bodies, some good, some bad. And it's up to the neutralizations and buffer solutions to save the day.
Well, let's start with what we love the most.
What's that?
Well, duh, food. As we eat, we don't just feed ourselves, but the sugar and the food that remains in our oral cavity feed bacteria. Did you know that there is an estimated 700 or more species of bacteria in our mouth?
Yuck.
Well, on the bright side, some of them help digest food, but others, like S. oralis and S. sanguineus, who are part of the layered bacteria colonies called biofilm, or better known as plaque, utilize and break down sugars to fermentate acids, such as lactic acid. This changes the pH in our mouth and leads to tooth decay.
But how do we prevent this corrosion?
That's right, neutralization, the acid with the base. Toothpaste contains calcium carbonate, a weak base that reacts with the lactic acid to produce harmless H2O and salt that changes the environment of the oral cavity that further declines the living conditions of bacteria.
As we follow the cycle, we find ourselves in the stomach.
What happens after we eat?
Our digestive system also exercises neutralization reactions. The food we ingest are digested using the corrosive properties of gastric acid. The cells in the stomach are busy producing concentrated hydrochloric acids, which has the pH of 2.
That's pretty acidic.
Acidic enough to dissolve iron nails. The cells in the stomach have to produce a mucus lining and add new layers of cells every 3 days, not to get digested by the acids. As the acids move with the digested food down into the small intestine, which does not have any protection against acids, well, the pancreas has to secrete an alkaline solution which is rich in bicarbonates.
That's a weak base.
This process neutralizes the acids from the stomach.
What happens when it doesn't work properly?
Sometimes tumors in the stomach will lead to the cells making excess acids, and H. pylori bacteria will also weaken our protective mucus lining in the stomach. If it's not fats, gastric ulcers form, which of course are followed by the burning pain in our abdomen. In this situation, we are usually told by a doctor to take the prescriptions of antibiotics or over-the-counter drugs that help reduce acids in the stomach by causing neutralization reactions with the base.
Leaving the digestive system, let's take a look at blood. Not as exciting as food, we know, but just as important, we assure you. The pH of our blood is a highly important aspect of our body.
Why is that?
Well, the pH of our blood has to be around 7.4 pH.
Why?
Well, if the pH drops below 6.8, acidosis, or goes higher than 7.8, alkalosis, the hemoglobin, or red blood cells that carry oxygen into our body and carbon dioxide out of the body, become deformed and change shape. This leads to the death of an organism. When the body exercises, the muscle produces hydrogen ions and carbon dioxide. In case of excessive exercise, the body uses another method because the hemoglobin can't deliver oxygen fast enough to the muscles. This method produces lactic acid, which enters the bloodstream. In these extreme cases, when the amount of hydrogen ions and carbon dioxide produced by the muscle exceeds the amount that hemoglobin can carry, Le-Chatelier's principle of equilibrium shifts kicks in and acidosis occurs.
Which we know leads to death.
The body responds to this drop of pH by the kidneys and liver removing carbon dioxide, hydrogen carbonate, and hydrogen ions from our bloodstream to help restore a pH of 7.4. The bloodstream also has defenses against a rise or drop in the pH.
But another properties of acids and bases are used, right?
That's right, buffer solutions. Within the bloodstream of our body, it doesn't have not just one or two, but three separate buffer systems, which are the bicarbonate system, the phosphate system, and the protein system. The main system in place that is found to have the highest concentration in the blood is the carbonic acid bicarbonate buffer system. The system can accept or donate an H+ ion, depending on the situation, to help maintain pH in the bloodstream. There are two secondary buffers. The first, being the phosphate system, is in a low concentration, but still an exceptional buffer. The second secondary system is the protein system. Proteins, being made of amino acid and an intermediate state, can also give or take hydrogen ions. These systems help maintain the pH in the body and preserve a healthy individual.
Now, you see, we are very close friends with acids and bases. They help us keep our teeth clean, our stomach healthy, and us alive and well.